Alright, in this chapter, right, we call it communicating information. We want to talk about how do we transmit information. So there are actually three main ways that we can do it. One is just someone talks and then someone else listens, which is no technology. So we are not going to learn this. Second one is wired technology, like your house phones using cables. So we're going to learn that as well. And the third one is wireless. For example, your mobile phones, walkie-talkies, and all those are wireless. So we're going to start off with wireless first. Now, contrary to what many people think, right? Actually, wireless communication is not that hard to do. The most basic form of wireless communication, how you want to generate wireless what do you call it? You call it radio waves actually. It's actually very easy. If you have a microphone, connect to an amplifier, what will happen is, remember your microphone will convert your voice into alternating voltage. So this alternating voltage is amplified and you pass it through an aerial. So what is an aerial? An aerial is just a normal wire, but only thing you strip off the insulation. So it's just a bare wire. So as the current goes back and forth, because the alternating voltage will cause current to go back and forth. As the current goes back and forth, following the frequency of your voice, because your voice frequency will be converted into alternating voltage of the same frequency. So the alternating current also follows the same frequency. Whenever the current flows back and forth, there will be acceleration and deceleration of electrons, which according to Maxwell will generate EM waves of the same frequency. So therefore you will generate your radio waves just by having an exposed wire. That's it. There's no other special equipment needed. Microphone, amplifier, strip of bare wire, that's it. You will get your radio waves transmitted. Then on the receiver side, if somebody wants to listen to your signal, you will need another bare wire acting as an antenna or an aerial. Why? Because your radio wave, being an electromagnetic wave, will consist of an alternating electric and magnetic field, right now. So the alternating magnetic field component, as it passes through the aerial, will induce an EMF according to Faraday's law. Because alternating magnetic field means changing magnetic field, so that generates an EMF in your aerial, which is then connected to amplifier to amplify, because after traveling through large distance, the signal will have been attenuated. That means there will be a decrease in signal power. So what will happen is, you need to amplify and then you will connect to your loudspeaker. So the alternating voltage will cause the diaphragm of your loudspeaker to vibrate according to the frequency of your alternating voltage. So you get your sound. So this is actually very simple. But they want you to know that we cannot do it this way, even though theoretically it's possible, but nobody does it this way. Why? There are two problems associated with this method. The first problem is the problem of interference. You see, if everybody transmitted radio waves using this technique, then if when we are all talking, do you know that sometimes our frequencies overlap? Because your voice may not have exactly the same frequencies as mine, but some frequencies will overlap. So therefore, if all of us talk at the same time, the aerial which is receiving is capable of receiving all the signals simultaneously. So you will get the interference. That means you hear everybody's voice at the same time. That's why you cannot do it this way. The second reason why we don't do it this way is because of the length of the aerial. Now let's assume that your voice is about 5,000 hertz. Let's say your voice is about 5,000 hertz. So what will happen is, what will be the wavelength that you're going to transmit? Because if your voice is 5,000 hertz, when it's converted into radio waves, also of 5,000 hertz, what is the wavelength of that radio wave? So we can use the formula, lambda equals to V over F. So where V is the speed of light in a vacuum, because it is EM wave, so 3 times 10 to the power 8, frequency is 5,000 hertz. Now, can you quickly calculate what is the wavelength? So you will get 60,000 meters, which is equivalent to 60 kilometers. Now, if the wavelength is so long, what is the significance? Now, your aerial is capable of receiving all the signals, but for effective reception, that means for best reception, you need to have resonance. And for resonance to occur, the length of the aerial has to be either half or a quarter of the wavelength. Now, if you don't have half or quarter wavelength, does it mean you cannot receive? No, but it's not very clear. Alright, so therefore, if you take 60 kilometers and imagine the length of the area, which is half of it will be 30 kilometers, or quarter of it 15 kilometers. So can you imagine an aerial being 15 kilometers long? It's just not practical, right? So this is why nobody uses this technique to generate radio waves and to receive radio waves, because it is just not practical. So which comes to our next part, which is modulation. So how do we overcome this problem, or these problems actually, is by using modulation. In modulation, what we will do is, we will use a high frequency carrier wave to carry your information signal. So when you use a carrier wave to carry your information signal, there are two types of modulation that we will learn about. One is called amplitude modulation. Now, what do we mean by amplitude modulation? That means, how do I use the carrier wave to carry my information signal? Is by modulating the amplitude. Okay, let me explain to you. Do you realize that your carrier wave has a much higher frequency than your information signal? Your information signal is, for example, the voice that you are trying to send using your radio wave. That's called your information signal. Sometimes they call it audio signal, because on the radio, what information is in the form of voice or sound, right now? So sometimes they call it information, sometimes they call it audio. It means the same thing now. So the carrier wave is high frequency, so that the wavelength is shorter. So when the wavelength is shorter, then the length of the aerial needed to receive it will be shorter. Example, right? If you think about the aerials in your car, are they very long or very short? Most of them are very short, right? Why? It's because the frequencies that we use as the carrier waves are, for example, like your Hits FM, which is how many? 92.9 megahertz. Now, 92.9 megahertz is, can you calculate the wavelength? So lambda equals to 3 times 10 to the power 8 divided by 92.9 times 10 to the power 6. So what do you get the wavelength to be? So you get 3.2 meters. Oops. 3.2 meters. Now, if you take lambda over 4, it will be how much? Divide by 4. 0.81 meters. So, can you see that it's less than a meter long? So, therefore, it becomes visible. Do you understand now? So, by how do we make the carrier wave carry the information signal? I'll show you later. But remember, there's another problem that we had just now, which is interference. So how do we avoid interference? Is that every radio station uses different carrier frequency. So example, if you are using Mix FM, it will be 94.5 megahertz. It means it's a different carrier frequency. Or Light and Easy, 105.7 megahertz. So different carrier frequency. So when you have different carrier frequencies, even though your information signals may overlap, doesn't matter, because we are using different carrier frequencies to carry the information. So we just have to tune to that carrier frequency that we want. So that way we will avoid interference. Do you understand that? So let's talk about amplitude modulation first. So how do you do amplitude modulation? Now, amplitude modulation or frequency modulation for that matter is not superposition. That means you are not adding the carrier to the information to produce a resultant wave. Wrong. It is not. It is not adding. Modulation is adjusting the amplitude if you are doing amplitude modulation, or modulation is adjusting the frequency if you are doing frequency modulation to carry the information. Example, if you want to do amplitude modulation, if this is the carrier wave that you're sending out, and this is the information signal that we want the carrier wave to carry, we will modify the amplitude of the carrier wave according to the displacement of the information signal. When you have positive displacements, I will make the amplitude bigger. When you have negative displacements, I will make this amplitude smaller. So I will keep adjusting this amplitude according to my information signal. So the more positive the displacement, the bigger the amplitude will vary. So the more negative the displacement, the smaller the amplitude I will create. So what you will notice that after modulation, which is this, which is not superposition, now you're adjusting. So imagine you have an oscillator, electronic oscillator that oscillates generating this wave. Because of the information, it will adjust the amplitude. That means it will still oscillate, but it will change according to this. At first it will oscillate small, then big, then small again, then very small, then big, then small again. So it will adjust the amplitude while maintaining the same frequency. So you will notice that after amplitude modulation, if I were to draw an outline of the shape of the wave, do you notice that it is similar to this? So that's how it carries the information signal. So when this wave enters the area of your radio that you want to listen, you will get this. So in your radio, you will have a demodulator. So a demodulator will read this, and from here, it tells the oscillator in your car radio to produce this. So it is not like taking this signal and then extracting out the signal from here. No, it generates a new wave by looking at this. So it looks at this, it says, okay, the amplitude is big, then small, then big. So it will tell the oscillator to oscillate and give you back this wave. So that goes into your speakers, and then you will hear the sound. So that is called amplitude modulation. So what is the definition of amplitude modulation? You can look at the next page. The amplitude of the carrier wave is made to vary in synchrony with the displacement of the information signal. That means you vary the amplitude according to the displacement of the information signal. The frequency of the carrier wave does not vary. So frequency of the carrier wave does not vary, so it's very important to understand the frequency does not change at all. The variation in the amplitude of the carrier wave is a measure of the displacement of the information signal. What does it mean? That means if you want the amplitude to be bigger or smaller by how much, it depends on the displacement of the information signal. If it's a very positive displacement, then the amplitude becomes very big. If it's a very negative displacement, then your amplitude becomes very small. The rate at which the carrier amplitude varies is equal to the frequency of the information signal. So what does it mean? Now, if you look at the graph again, you will see that how many times the amplitude changes from high to low to high in 1 second actually depends on how many times the information signal changes from peak to trough to peak in 1 second. Every time you have a peak, it's highest amplitude, trough, lowest amplitude, peak, highest amplitude. So what they're saying is the rate at which the carrier amplitude varies. That means how many times it varies from high to low to high in 1 second depends on actually this frequency, how many times it changes from peak to trough to peak in 1 second. Now, when you produce amplitude modulation, which is actually this wave, remember I told you it is not superposition between the carrier and the information, right now. So the oscillator will just adjust. It means it moves small, then big, then small, then big, then small, then big, right now, to generate this wave. But if you were to pass it through a frequency analyzer, so a frequency analyzer is a machine that if you pass this wave through it, it will tell you what are the hidden waves within this wave. As in, what are their frequencies and amplitudes. Now, what do you mean by hidden waves? If you look at this wave, it seems like there's only one wave right now. But actually, inside here, you got 3 different waves hidden. Example, if you look at white light from your fluorescent light tube you'll see it's white color right now. But if I were to pass it through a prism or through a diffraction grating, then suddenly you see a rainbow 7 colors right now. So, but you never expected that inside this white light had 7 different colors, correct or not? So similarly, when you pass this wave, the amplitude modulated wave, through a frequency analyzer, it will tell you what are the hidden waves, that means what are their frequencies and what are their amplitudes that make up this wave. But of course, we don't go and purposely create the three waves, the hidden waves. We only do amplitude modulation. That means we just move up and down with big amplitude and small amplitude. That's all we do. But after that, it consists of three hidden waves. Just like when we want to generate this white light from the light tube, we just on the switch, there's electricity passing through the tube, then it generates white light. We never purposely generate all the 7 colors combined together to give you white light, right? So same thing, when you're doing amplitude modulated wave, we just adjust the amplitude and we get this. But then once we pass the frequency analyzer, there's, hey, inside got 3 different waves. So what are the waves which are always hidden? It is standard. For amplitude modulated wave, you will always have one wave which is the carrier wave having the same frequency as your carrier wave. Example, like in the previous example, maybe you, because in the question, okay, let's say I give you let's say the carrier wave is 50 kilohertz. And let's say the audio, which is the information, is 5 kilohertz. So we modulate the carrier wave using the information, and let's say we get this. Then we pass it to the frequency analyzer. It will tell you there will be one wave of 50 kilohertz present with the highest amplitude. But also, there are 2 more waves hidden, which is FC plus FA. That means 55 kilohertz. Wait, let me just write nicely. 55 kilohertz and 45 kilohertz. Now, where did this 45 and 55 come from? Now, we never purposely generate it. It's just that automatically it will appear if you do amplitude modulation. Just like I turn on the light, I get white light. But then automatically inside got 7 colors. Like that. So I will generate an amplitude modulated wave, automatically got 3 waves inside one. So why is it important to know the 3 waves here? It means that even though you are transmitting the wave at 50 kilohertz, actually you are occupying between 45 to 55 kilohertz. So the range that you occupy, this range is called your bandwidth. So which means to say nobody else must operate within 45 to 55 kilohertz, otherwise there will be interference. So even though you are sending out the wave at only 50 kilohertz, but in reality, you are occupying 45 to 55. So the range of frequencies you occupy is called your bandwidth. So it's called 10 kilohertz bandwidth. Do you understand? To get the bandwidth, you just take the highest frequency component minus the lowest frequency component. You don't believe, you take 55 minus 45 and you get 10. Do you understand? And the 2 waves here, they call it the sideband. So you need to know the name. This is called carrier. This is called sideband. So the 2 sidebands will have lower amplitude than the carrier wave. How much lower? It's about 1/3 of this amplitude. Okay, so around 1/3 when you draw. When you draw the sidebands, it is about 1/3 of this. That means you add up this 55 plus this 50 plus this 45 kilohertz waves, you will also get this one. If you wanted to add them together by superposition, you will get this. But of course, we never do that. We actually use amplitude modulation to create this, and then we notice that inside got this. Okay? Now, usually when people talk, they don't talk with an information signal like the previous page like that. Do you ever talk like this? Constant amplitude and constant frequency? You don't, So our voice is more likely to be varying amplitude and frequency. Example, big amplitude, big frequency, then low amplitude, low frequency, then big and small. You keep on varying, right? So if this is my information signal, and I use it to modulate my carrier wave, I won't get a very nice graph like previous. Because last time when you use a very nice information signal like this, your amplitude modulated wave also very nice one. Big amplitude, first you start like this, then small, then big, then small. A very nice pattern as well. But since your voice is not like this, so the amplitude modulated wave also won't be like this one. it will be something more like this, more random like this, right? So how do we actually draw the graph, the frequency spectrum for this type of graph? Now you need to understand, wait, let me just delete this. So let's say this is my frequency, my amplitude modulated wave, okay, my amplitude modulated wave here. So what will happen now is that, let's say my audio frequency, so when we are talking, we have an audio frequency that varies between, let's say 2 kilohertz and 5 kilohertz. And at each of these frequencies, our amplitude also varies. So this explains how our information signal will look like. So our information will be high frequency, low frequency, and all those stuff. So low frequency will be like this, high frequency will be like this. Amplitude also can vary, so sometimes got big amplitude, sometimes small amplitude. So when we modulate, we will modulate the carrier wave and we get this. So what will you get? The frequency spectrum. The main idea is still the same. You will still have your carrier wave in between here, but the difference is your sidebands are no longer just two lines. What will happen is your sidebands, remember, is always FC plus FA, but your FA has a range between 2 to 5. So you will start off with FC plus 2 and go all the way to FC plus 5. So you can either draw like this, that means start from FC plus 2 all the way to FC plus 5, or if you look at the past years, they most likely, wait, let me just adjust a bit. They will most likely draw like this, amplitude, frequency, they will draw the carrier wave, then they will draw the FC plus FA, let's say FC plus 2, all the way to FC plus 5 kilohertz, right? And then in between, you got also other frequencies, right? So you just draw a jagged line. And on the left hand side will be FC minus FA. So FC minus the lowest FA, which is FC minus 2, all the way to FC minus 5. And in between you have different frequencies and amplitudes, so you just draw a jagged line as well. So what they will do is, sometimes they will draw this way, FC plus FA, FC minus FA as like a maximum graph, or sometimes they will just draw jagged lines like this. So the jagged lines show you that they have different amplitudes at different frequencies. So what is your bandwidth? Your bandwidth is still measured from lowest to highest frequency, so this is still your bandwidth. So that means this is the range that nobody else can use. Example, if let's say you refer to this example, FC plus 5, FC minus 5, you minus these two, what do you get? 10 kilohertz, right? So your bandwidth is 10 kilohertz. That means within, let's say your carrier wave is 50 kilohertz, within 45 to 55 kilohertz, also no other radio stations must use. Understand? So don't worry. So there are two types of graph. One is where your previous slide, when you have only a constant amplitude and constant frequency for your information signal, so you get 3 lines. If you have varying frequency and varying amplitude for your information, then you will get this jagged line. And this graph, you will notice that sometimes they will, instead of using amplitude, they will use voltage, also can. Instead of using voltage, sometimes you use power, also can, because all three are directly proportional. So whether they ask you to plot power versus frequency, voltage versus frequency, or amplitude versus frequency, no worries, same graph. Okay?